It takes about 8 months to reach Mars, 13 for Jupiter, and over 100 for Pluto. But due to health threats exposed in outer space, most astronauts have to cap their missions at a mere 6 months.
Space radiation is one of the biggest culprits preventing long-term human spaceflight. Without Earth's natural defenses, prolonged exposure causes cancer risk to skyrocket. In addition, cells degrade at an accelerated pace, and equipment is more prone to malfunctioning. Radiation poses as one of the biggest hurdles in human spaceflight, and alleviating its effects is critical for space exploration.
Radiation manifests in two forms: charged particles and electromagnetic waves. Our project ARES stands for Anti-Radiation Exposure Shield, a system designed to deal with both forms at once.
In the case of charged particles, we took inspiration from the Earth's own defense mechanism, a massive magnetic field that can deflect cosmic rays. These magnetic fields can also be created by strong electric currents. To minimize energy use, we focus on superconductors to conduct the electricity. When they pass their critical temperatures, electric resistance drops to virtually zero. This way, we can maximize current flow with minimal energy use, thus generating strong magnetic fields.
And outer space already has the benefit of cold temperatures, easily allowing superconductivity. If we encompass a spacecraft within the magnetic field, high-energy particles will no longer be a major threat to the missions.
Turning to electromagnetic radiation, we plan to use metals to absorb the direct EM waves. Normally, the energy will cause neutrons and electrons to scatter from the metal, which is another source of radiation in itself.
This can be resolved with hydrogen-rich materials due to the fact that hydrogen typically does not contain neutrons, thus causing less secondary radiation. We plan on tackling these issues together as one package, with alternating layers of shielding and hydrogen-rich materials in order to better gradient the absorption. Venturing into outer space means leaving behind the protective cradle of Earth. To move forwards, humanity must be able to protect itself. In an age pressed for resources, inspiration, and solidarity, expanding beyond the crib is an essential goal for us to partake.
With ARES, missions to Mars and beyond can leap one step closer. With ARES, astronauts can finally thrive in the only place where political boundaries cannot be seen.
With ARES, we hope to rid the future of space radiation exposure and erase the biggest obstacle preventing long-term missions for outer space exploration and for the future of humanity.